Yes.
Yeah. Okay, so welcome to Pathology AI. Like I said again, it's an AI-powered histopathology slide analysis for like research and education by medical scans. So
Can you
let's
just
begin.
uh, do a slideshow of this one?
Okay, yeah.
Yeah.
So what is the problem basically? Digital pathology is growing at a faster rate than the tools behind it to build. The medical field keeps on expanding, more technologies, breakthroughs are coming out. So we need proper tools and devices to combat with those, like to keep on moving up with those breakthroughs. So right now, digitalized slide volumes are outpacing pathologist workflows. A gap has been reported in the field, straining the times in both clinical and research areas and the inconsistent review, there's a visual grading showing measurable observer variability. Mostly on these types of cases, well-documented limitation of the assessments that are done with histopathology. And then the tooling we use, research and teaching labs typically rely on like more single-purpose tools for viewing, annotating, and reporting. They're not really that affordable. They tend to cost a lot of money, and platforms for like they're like basically extendable platforms for AI system review, basically outside of these clinical systems. They're quite expensive, and the clinical themselves, they're more focused on the actual like material, like supporting it. They don't have time to create AIs. They need like proper employees to create those. So they're just like mostly like in a gap, basically. So let me just Okay, so meet PathologyAI. So what is PathologyAI is basically a research platform and upload and analyze, visualize, report, and collaborate on these histopathology slides. So there are four stages basically. So PathologyAI analyzes these images by by its own computer vision and recurring neural network. So basically, it analyzes nuclei count and its specific PyTorch architectures like ResNet, DenseNet, EfficientNet, basically on pandas, and then it's implemented and ready for training. So then you can visualize, once you incorporate those images, you can visualize them with like, you can zoom them in, specifically gap into this one section you want to focus on. You can analyze heating maps, tissue density, density. Then after all the images are created, Pathology AI, it generates a report basically in PDF, CSV, JSON, and then you can view the report. It is all the necessary information. It's like basically like a full research report, like 1 to 2 pages. And then after that, Pathology is there's like some collaboration in between it. So we have like you can put your comments in, you can log it in, you can save your images exactly. And I've also built an interactive AI assistant in Pathology AI called Hoot. Later on, as I demonstrate my project, I'm going to show you him. But he's like, basically, if you have any questions about like what Pathology AI is, like the field around it, what's like statistics, what measure, what data we have, you can ask him. So moving on. So Pathology AI, with AI analysis and explainable AI. We have proper scanning, simulated scanning tools for this network. We have an inventory, barcode, and rack location tracking. We have our ROI annotation. Basically, there's manual labeling for like building groundwork. And like if you want to focus on a specific area in your scan, you can like go to the ROI and annotation. Then we go over to patient reports, generates a report generation, explores like a PDF, CSV, JSON. And then finally, we have Hoot, our own AI coordinator. He's basically this assistant that's available on every page for findings and navigating around through the platform. So every prediction is labeled. Nothing here is pretends to be more than it is. So basically, Pathology AI, we have real and working um, organ disease registry, authentication, Grad-CAM explainability, deep zoom slide viewers. Our real code architectures are exactly these like pandas modules. ResNet 50, DenseNet 121, and Vision Transformers. All of these are fully integrated into the platform, and their outputs are acting as basically like placeholders into the application. And as well, we have Grad-CAM, UNet, segmentation, and assembling augmentation are implemented, but they're like awaiting train weights to function. So This is intentionally not built. So basically, cancer staging, survival risk prediction. This is not built into the platform, but it's basically a generalization of pathology AI scans in general. And um, so basically, built to extend pathology AI is basically has all these module architectures designed for adding organs, modules, and integrations. We have 10 organs in our disease registry, 5 real PyTorch backbones, 3 export formats, and 1 line of code to add a new organ. So I used Python and Streamlit to create the architectures. I used OpenCV and PyTorch. I used SQLit. I used a fast API layer, and I used a Docker. So what's next for Pathology AI? So basically, our architectures are on public label datasets, including Camlion, Panda, Breakus, TCGA, and basically any other reported standard a metric. So it's to migrate from SQLite to managed post GRE SQL for durable multi-user persistence in the shared and more shared research environment. And you can add SSO or auth for institutional authentication. So that was all my presentation. And is it okay if I demonstrate it?
Yeah, sure, go ahead. Yeah.
Okay, so here's Pathology AI. So here's all of our
Can you
capabilities. And
Google Meet window?
okay.
Not this, the cross sign. No, oh, you just stopped sharing.
Oh yeah. I'm gonna like I, I just want to like open it on its own tab, but I also want you guys to like see the PDF reports.
Okay. Okay.
Okay, so here's Pathology AI. To get started, you have to click upload a slide. If you don't have an account, you can create one, but I have an account. So I'm just gonna type in my information. And here we have, so this is the dashboard. It's basically a summary of what we've done so far. From our active slides, our mean confidence, our nuclei detected, and our cases analyzed. It's basically a summary in general, and it doesn't apply to necessarily to your case because you haven't uploaded your image yet. So then you click on upload, and I'm going to upload an image. Yeah, so here you can see, you can preview exactly what this image is. You can feel free to rotate it. You can increase its brightness, increase its contrast, and you can reset these edits. So here we have a deep zoom viewer. Like I said, this is basically going to like zoom into specifically on a specific area. And then we have our AI analysis. You can choose your own model architecture. I'm going to use DenseNet. I'm going to focus this on, let's just say kidney cancer. So I'm going to run this AI analysis. And as you can see, we have a 61.4% confidence rate, a low risk level. Here's our processing time and the model we used. So here we have our own bar graphs for the confidence and our own tissue quality, our tumor heuristic percentage. And here's the heating maps we have. And here's the nuclei detection preview. Oh, yeah. So on the bottom right, there's this, here's Hoot is basically this AI assistant. So you can ask Hoot any question. So I'm going to type in what is a heating map? Give it to me in 3 sentences. And who can generate that for you? So I'm going to go to results dashboard. And then as you can see, here is all the predictions we have for that the AI is calculated, or predict normal class. It's not that serious. There's no risk level. This is basically healthy tissue. This is a pretty good sample because there's no actual disease involved in it. And as you can see, here's our nuclei overlay, our heating maps. Here's the charts we have. But there's a high percentage of healthy tissue, so this is good. Here's the area we have of the nuclei distribution. Here's a confidence rate, and here's the applied proper like line graph that we have. So the red represents the healthy tissue, and here you can download it into like JSON, CSV. You can see, I'm gonna save it to my profile, and you can add comments into this. So this is my histopathology. Yeah. And here we have our own explainable AI. So here's the explanation overlay. So the AI is based on all the previous like data. We've created this own like heuristic, this own explanation that this AI has created. And then we go to tissue detection, run your tissue segmentation, and you can see the area we have, the centroids we have, basically the necessary data. And the tissue overlay is outlined properly. So then we go over to cell detection and basically the nuclei area. So this is a more compacted region, but if you increase the area, you can see it's more like varied and spaced out. So it's good to keep like a very like low rate basically. Yeah. So then we have our proper statistics placed right here, our mean confidence rate, the sessions we've ran, and a summary of what we have. This is a really good tissue quality, and we've had good confidence, good findings. As you can see, the confidence is really appropriate to the mean confidence. And here's the cases analyzed from the dashboard slide. Here's our all our necessary model architectures, and here's our conference collaboration. So here's my scan queue. Let me upload another same file. So here, yeah, here's the basic confidence rates we have. You can download this, and it's basically this is a very normal finding, low risk rate, a good confidence measurement, and when you go to slide inventory, you can search up. It actually saves your saves all the necessary details that you've had from that previous slide. From all the previous scan. So then you go over to comparison, and it's basically if you have like two analysis, will compare exactly like both of the scans, and it will like interpret it in its own data. So then after that, we go into patient report. I'm going to type in like John Doe, 17 years old, male, and generate PDF report. Download this PDF report, and it downloads that PDF report for you. So then we go to ROI annotation, and this is basically when a specific area is segmented properly. You can leave your optional notes like this is the area I want to focus on. And you can save that region and saves the suspected tumor. You can download it. You can also download it as well. And here we have the audit log, basically all the proper scans that we've done. And it's basically who did what and when exactly. So all the details we've captured, all the necessary images you've put in, exactly your history. And then here's basically the profile. You can go back to your slides, and that's all I have for you.
Yeah, you can stop sharing now.
Okay.
Yeah, I mean, the presentation was good.